Okay. That third step came from foiling these two. X to the fourth, 9x squared, 1x squared, and 9. Then we just combine those steps. Once you've gotten to where I am, what's the really only thing we have left to do? Plug in -1, set it equal to 20. So that's -1 to the fourth plus 10 times -1 squared plus 9. So that's 20 equals 20a, which means a is just what? Whoa, 1. So there's really nothing to write there. So your finished product is simply what's in blue. Sure. In fact, I'll tell you what, I'll do you one better. Turn to 2.5 in your book, and I'll do 26 or 28. I'll do one of the two you have to do tonight. Wait, hold on. It wouldn't be 26 or 28, it'd be 26 or 30. I'll do 26 or 30. Alright, just 1 second. I'm letting people copy that down real quick, and then I'll do 30. Thanks. Yeah, I do have mixed 30. Good. Does anybody need me to leave this on the board? Yes? Yes, sir. Where? It is a equals 1. But see, when you multiply through by 1, it doesn't change anything. So you can really just leave it off. Yeah, you would get a equals 1. And we discussed that, I just never wrote that. On the board, leave it. All right, number 30. Here we go. What's our degree going to be when we're done? 4. Excellent. Here we go. Factors time. F of x. Now this was straight from your homework today, so you definitely want to write this one down as something else. Like it's literally in your homework. A. We don't know what that's going to be. What's our first factor going to be? X plus 2. What's our next one going to be? Very good. Just the opposite of these two. And then our last two are those two imaginary. Now it occurs to me I probably shouldn't have sprinted through that imaginary explanation earlier. Let me show you why it's always going to be x squared plus something. If you FOIL these imaginaries, you're going to get x squared plus xi minus xi, which cancel, minus I squared. Well, that's minus, and what's I squared? Negative 1. Giving you, after those cancel and this becomes a minus a negative 1, x squared plus 1. And it's always going to work out like that. That's why I kind of skipped that step in the past, but I shouldn't have done that. Now I'm going to FOIL the first two terms. That'll be x squared plus 1/2 x plus 2x, which is 2 and 1/2 x, or 5/2 x. And then 2 times 1/2 is 1. So that's just the first two pairings FOILed. Now we gotta distribute x. I'll take these two and multiply them by all three of these individually. X squared times x squared. X squared times 5/2 x. 5/2 x cubed. X squared times 1. 1 times x squared. 1 times 5/2 x. And 1 times 1. The only like term we have to put together are the 2x squared, so I'm just going to real quick do that right here. X squared plus x squared is 2x squared. It's the only like term we had to worry about. Now what do we do? Plug in 1. Very good. So that'll be A equals, or 18 equals, 1 to the 4th plus 5/2 times 1 cubed plus 2 times 1 squared plus 5/2 times 1 plus 1. So that's 1 plus 1 plus 2 is 4 plus 5 is 9. So that's 9a. So what's our a value going to be? 2. Once you divide both sides by that 9, your a is going to be 2. So you plug your 2 in for this a, distribute it, and you're done. So that's going to give you 2x to the 4th. 5/2 times 2 is just 5x. Did you have a question, Roger? This one? This one, right here? When I didn't factor, I FOILed. Because that's 1/2 x plus 2x. So that's 2x plus 1/2. You could have written just 2.5 x if you preferred. I just like mixed fractions better. The reason I prefer, not mixed, improper fractions, is because like right now, what am I doing? I'm multiplying 3 by 2. And if you have it written like this, well, 2 times this is just going to be 5. Whereas if it was 2.5, I would then have to convert it to 5,000 for it to do that. So I just like to skip that step and go straight to improper. But if you leave it as mixed fractions, that doesn't make you wrong. Plus 4x squared plus 5x plus 2. And we're done. That's the only real new thing we're learning today. Yes. Yes, it is. All I did was plug in a 2 for A. Well, that's the only thing that's hard that we're going to do new today. Yeah? Where? Here? Oh, I see I plugged 2 in for A. And then I just distributed. That's the only reason I needed the parentheses, was to remind me to distribute to all of these. Yeah. Questions? Okay. Really, the only thing left is for us to do stuff up to the 4th and 5th power where we do. Now, this slide is the oddball. You're not really going to need this for anything else. Really, we're going to go right back to what we were doing yesterday, is finding all the zeros of these functions. The only other thing we're going to do before that is really, you'll never need it unless you want to use it. It's just a hint. It's a way to help you narrow your search. For instance, does anybody need me to leave this up there? Okay. Now, let's say, while they're writing, I can just explain this. Let's say we have one of our 4th ones, and our P over Q list is like 30 numbers long. You don't want to look through all those numbers. So all I'm going to show you on the next slide, and again, you don't have to use it, is a way to help you narrow your search. I'm going to show you a way to say, oh, I'm more likely to find a positive one. So you might try your positives first. Or I might even show you, it might be where, oh, I'm not going to have any negative ones. So you don't even have to look at those at all. That's the only purpose of the next slide I'm going to show you. So if you don't wish to use it, you may discard it from your mind. I don't even think there's a test question about it. But it can be helpful. Chris, I'm sorry, did I give you enough time? Okay. It can be helpful for that. The Descartes rule of signs. This is so simple. Look at number 33. Okay? I'm going to count all the sign changes that happen. Positive to positive, that's not a sign change. Not a sign change. Not a sign change. Were there any sign changes? No. There were 0. Now, don't ask me why this works, because I don't know. There were 0, so that means there are 0 potential positive roots. Every time there's a sign change in your problem, that represents a potential positive root you might have. So if I asked you to find the roots of this, you give me a P over Q list, I can tell you confidently right now none of them will be positive. Which means you could look all for the negative one. You don't even have to worry about this. What would our P over Q list be? Plus or minus 1, 2, and 4? You don't have to worry about positive 1, 2, or 4 because we have no positive ones. It's just the sign changes. Now if there's 3 total and 0 of them are positive, how many have to be negative? Well, I really wish I'd done this in the other order. Right, the last 3, right? There's a potential 3 negative roots. Now, why do I say potential? What also happened yesterday that may happen where it won't cross at all? Imaginary. But imaginary is always coming how many? 2. So anytime you get a number for this, you have to take into the possibility, or there could be 2 less. So really this is 3 or 1. There's going to be 3 or 1 negative real roots. So if I ask you to solve this, you cut your list in half of what you need to look for, and you can just look for the negative ones. That's the whole purpose of that, help you narrow your search. Sometimes you'll get like, well, let's look at 37. You might get it right there. How many sign changes are occurring? Let's see, 1, negative to negative is none, negative to negative is none, negative to positive. So 2, right? So there's 2 potential positive. Of course, you always have to take into account imaginary, so 2 or 0. Always go down by intervals of 2. So how many is left for negative? Well, if there's 4 total and potentially 2 positive, then there could be 2 or 0 negative. So did it help me here? No, it didn't help me at all because there's an equal possibility of finding either one. But it's so quick, it's not like it takes you a lot of time. These are what you hope for. You hope for ones that give you a 0 or maybe a 3. That way there's none left to be negative so that you know, hey, I don't have to worry about those. That's the whole purpose of this. Let's look at 35. How many total are there going to be? How many sign changes are there? 1, 2, 3. 3 potential positive ones or 1. So how many are left for negative? So I know I don't even need to bother looking for the negative roots. Questions? Descartes rule of signs. Kind of a neat little trick. If there were 3 total and 3 of them could be positive, then none of them could be left to be negative. And that's it. Now, Let's say you had one with a 5, degree of 5, and you get 4 positive, 1 negative. I personally would start looking for the positive. I think I have a better chance of finding those. That's not guaranteed, because I could have 4, 2, or 0, right? So you may be looking at that 0 possibility. But if I have a heavy number disparity, even if one of them is not a 0, I still will start looking for the bigger number, and hopefully it'll help me. So let's put all this together and work a hard one. The cubed ones are the exact same as we did yesterday, so let's look at a fourth one. How about 45? 45. And then I'll work 51, and hopefully we'll be done. Now, the directions are a paragraph long. Essentially, all they say is use any means necessary to find the roots. First things first, I'm going to construct my P over Q list. Well, let me get my P's first. My P's are going to be 1, 2, 4, and 8. Positive or negative. And what are my Q's? Oh, just 1. Well, that's lucky. I didn't choose this one because it would be easy. How many sign changes do I have occurring here? Well, positive to negative, the 1, but just 1, right? So it means I have a potential positive 1 and negative 3 or 1. I'm going to start out looking for the negatives. It's not a guarantee to work, but I'm going to start out looking for the negatives because I think I have a better chance of finding one. So here I go. I'm going to try negative 1 first. No missing terms. Good. Drop the 1, multiply, add, multiply, add, multiply. Hot diggity, looks like we found it first try. We found one. Now, here's where it's different from yesterday. You're not ready to go into quadratic yet because we've lowered this from a fourth to a what? A third. I still need to take one more out to get down to the quadratic, the power of 2 equations. So, now remember, if one of them works, you always have to try it again. Maybe it's a double root. So let's try negative 1 again. Notice I'm using it for my depressed polynomial, not my original. So, drop the 1, multiply, add, multiply, add. Is this going to work? No, it didn't. So, now I think you said yesterday that we can't just erase, so I won't just erase. I'll just write it again. Let's try negative 2 this time with 1, negative 4, 16. Again, still using the depressed polynomial because I've already factored one thing out of it. Drop the 1, multiply, add, multiply. Oh yeah, this was lucky. I happened to find it quickly. There will be some that you have to work through 10 or 11 before you find one. That's just the way it is. Still not as bad as it used to be. Okay, so here's how we have successfully factored this right now. We have factored this down into x plus 1, x plus 2, x squared minus 6x minus 4. How can I finish this? You could factor it or just use the quadratic equation. So here we go. That'll be 6 plus or minus all over 2a. So that's 36 minus a negative 16, so 36 plus 16. Yikes, that's ugly. But I think this breaks down into 2 radical 13s. Is that right? I think I heard Ryan say that, so it must be right. Now these are not rational. That's why they're not on our list. That is a hideously irrational number. Only thing you can do now is finish it up. That's actually 3 plus or minus 1 radical 13 if you divide everything by 2. So our 4 answers, our 4 roots were negative 1, negative 2, and plus, well, that's not true, and 6 plus or minus 2, nope, what am I doing? I already reduced this. 3 plus or minus radical 13. There's my 4 roots. And sure enough, 3 of them were negative, and 1 of them was positive. Because 3 minus is going to be negative, 3 plus is going to be positive. Just like Descartes told us. Only time that's going to get harder is if you have to look for more of them during your P over Q check. We'll do one more together. Hopefully you'll feel confident you can finish it up. Are there questions on this one? Does anybody need me to leave this on the board? Okay. Just remember, when you take out your second one, you have to take it out of the depressed polynomial or it's not going to do you any good. Don't take it out of the original, because then you won't be down to a quadratic. We will work the 5th power one next, where we have to take 3 out. It is a yay. Very yay. Are we good? All right. Last one. First things first, P over Q's. My P's are 1, 2, 4, and 8, and my Q's are 1 and 2. So that's plus or minus 1, 2, 4, 8, and 1/2. Because 2 over 2 is 1, 4 over 2 is 2, and 8 over 2 is 4. So that's it. There's my P's and my Q's. How many sign changes do I have? 1, 2. So that's potentially 2 positive or 0 and 3 or 1 negative. They're pretty similar. I guess I'll start out looking for the negative because there could potentially be more of those. So let's try negative 1, 2, 7, negative 18, negative 8, positive 8, 2, negative 2, 5. Here's what I would do if I were you guys today. When I assign this later, I wouldn't even worry about solving them. Since you're only going to have about 20 minutes, I would work in your group and just find all the ones that work real quick. Because if everyone took a different number, you wouldn't all have to do 10 synthetic divisions. Right? Oh, yeah, sorry. Wishful thinking, right? Negative 7. So, like, for instance, let's say I was sitting in that group. I'd be like, hey, Amanda, why don't you try positive 1? Ryan, why don't you try positive 2? Bridget, why don't you try negative 2? Zach, why don't you try positive 4? Somebody find me one that works. I'll keep working on it. Dude! Yes. Yes. That's true. Thank you for pointing that out. This might work now. He correctly pointed out that I forgot my 0 for my x cubed. Ashton, I'm so glad you're here. Okay, so that should be fine. That should be the same. Here we go. Negative 5, positive 5. It's still not going to work, but I'm still glad that I know that. Okay, so, did you find one?
No. So it's the number of constants in positive.
Yes. All right, so let's try negative 2. I'm going to wear out my negatives first. We'll say it again. Because, yeah, I had a slightly better chance of finding. Now, it may be all in vain. It may be I can't find a negative one because they're all irrational. But that's a risk I'm willing to take. Negative 4, 3, negative 6, 12. Ooh, this looks like promising. 12. Yes! But I have to find 3 of them, and I've only found 1 so far. But I'm going to stick this one up here in the corner in my answer box, which I just invented. Now, when one works, what do you have to try next? You have to try the same thing. Maybe it's a double. So let's try negative 2 again. That would be awesome if it worked twice. Negative 4, negative 1. Ooh, you see how my negative numbers are lining up? That's normally a good sign. Yes, it is a double root. Negative 2 worked again. So I have to find how many more? Just one more. Let's try negative 2 again. Maybe it'll take us to the promised land. But negative 2 is my hero right now. I'll do it all for you. Thanks, negative 2. You're the best. I'm stopping. Is it because of the voices? Let's try it. Drop the 2. It's not going to work, Ryan? Oh no, an odd number. That's not a good sign. 10. Oh, it's not. Dang you, negative 2. You've forsaken me. Okay, well, that means I'm going to have to try a different one. We had a good run with it. So, my depressed polynomial, don't forget to keep that with you. You don't want to go back to the original. That would undo all your work. So let's try negative 4. Well, it's going to take me forever to find this last one. 2, multiply. Oh, this isn't looking good. But on what? Oh, I felt it before. Do you think I've never been in your shoes? What is that supposed to mean? And that's probably true. But that means I struggle in my tests and homework. Okay. Well, darn. Negative 4 didn't work. So let's try negative 8. This is why we should all try different numbers. Oh, great. This probably isn't going to work. Yeah, that's not going to work. 120. Yes! Marco's on my team. Okay. Good job, Marco. Let's try. You said positive 1/2? Marco! You said positive 1/2? Thanks. That makes me happy. All right. 1/2. 2, 1, negative 4, 2. Teamwork is awesome. Drop the 2. Multiply. Add. Multiply. Are you sure? Wait, but maybe negative 1/2 works. That'll make that a negative 1. That'll make that a 0. That'll make that a 0. That'll make that a negative 4. And that, oh no. Dang it. What a tease. Negative 1/2, you're a jerk. What? I got those. Okay, I'll go back and look at that in just a second. Latifa, you said, where did I get that from? After I got negative 2 to work, remember I kind of factored that out, and this is what's left. So then I tried negative 2 again with my new polynomial, and got this, and that's what, oh, that's what you're saying. Negative 1, okay. So that one may have worked too if I just didn't do it right, and this one. Darn you, Crawford. Get your stuff together. All right. So go back to positive 1/2. Marco, I'm sorry if your name got soiled. It shouldn't have. What? Okay. It is still wrong. So we're still going to try negative 1/2. I re-soil your name. Where am I messing up?
I'm going to clear my name. That's a positive 1.
What? All right, it's a positive 1. Well, what are you saying? That I can't multiply?
No, I'm implying that.
Well, you very well implied it. So that's 0, negative 4. Looks like he got lucky this time.
There, that's what I had.
I am not worthy. Okay. And that gives you x squared minus 4. Ooh, that's an easy one to factor. We don't even have anything left to do. What does that factor into? Wait. That can't be right. Well, anyway, 1/2 goes up here. Please tell me I messed this up somehow. 2x squared. Right. Man, see, teamwork. Show your work on your test. It's so easy to get lost in translation on these things. Okay, so, but if there's no b term, we don't really need quadratic. Just solve. So 2x squared minus 4 equals 0. Add the 4. Divide by the 2. And what is that, plus or minus the square root of 2? And there are your 5 answers. 3 negative, 2 positive, just like we thought. What? 2x squared minus 4. Okay. And then we just solved it for 0. Added the 4. Divided by the 2. And took the square root. If you don't have a b term, if you're missing your b term, that's much easier than doing the quadratic. Just solve it. And we're done. We found all 5. Thanks to no small part to Marco. And Ryan. What? Until you find all 5. No, see, it did. We just didn't write those out. See, the blue portion over here was all that. When we first factored out a negative 2, we got 2x to the 4th, 3x cubed, negative 6x, 2x cubed, 3x to the 3rd, minus 6x squared. See, that was the 4th. We just didn't write it out because we just needed to keep going. We took 3 out and eventually got down to x squared. Now, so that you can maximize the rest of your time, I'm going to go ahead and give you your assignment. Freeze, Daniel. Freeze. Okay. When in doubt, hit it. Here's your assignment. People were writing. Now, just add that to yesterday's. You've already done 2 through 22. In fact, Marco, instead of writing this fresh, just change those numbers. You've already done most of this. And these 2 are bonus. You don't even have to do them. So, yeah. 40, 44, 48, 52. There's only 4 of these. So you have like 4 here and like 5 there. You have like 9 more problems. So luckily you have a pep rally today for which you can, yeah, it's not going to help actually. Never mind, disregard. I was going to say you could do them during the pep rally, but then you have to be cheering during the pep rally. You have to be rallying the pep. What? You get it? Yeah, here. Oh, snap, that was mean. Oh, I need to turn off the lesson.